Hi there, welcome. In this session, we will learn how to find solutions or roots of a given quadratic equation by factorizing method. Let's begin. Okay. Learning objectives. First one, how to find solutions or roots of a quadratic equation. Here you need to understand solutions or roots, both are same. You can call either way. Second, different methods to find solution of a quadratic equation. We have different methods. What are all they? We'll discuss. So these two are the main learning objectives of this session. Okay. Now, solutions or roots of a quadratic equation. What exactly solutions or roots for a given quadratic equation? That we need to understand. Okay. Begin. Let p of x equal to 0 be a quadratic equation. Then the zeros of quadratic polynomial p of x are called the roots of the quadratic equation p of x equal to 0. Again, here you need to remember zeros of quadratic polynomial are same as roots of quadratic equation. And we know when a quadratic polynomial equate to 0 or any constant becomes a quadratic equation. Okay. So let's see with an example. Example, p of x equal to x square plus 6x plus 5 is equal to 0. This is a quadratic equation. Here the roots of this quadratic equation are x equal to -5 and -1. So how we got these roots, we'll discuss later. Okay. For an instance, you should understand for this quadratic equation, these are the roots or solutions. Okay. Next. In other words, a real number alpha is said to be a root of a quadratic equation ax square plus bx plus c is equal to 0, where a not equal to 0 if a alpha square plus b alpha plus c is equal to 0. Here you need to understand very importantly, a not equal to 0 in a given quadratic equation. What is a? A is x square coefficient. What happens if a becomes 0? If a becomes 0, 0 times of x square, 0. Then this becomes bx plus c equal to 0. Becomes a linear equation. This is no more be a quadratic equation. So, a cannot be 0. Okay. So, a real number alpha is said to be a root of a quadratic equation ax square plus bx plus c equal to 0, where a not equal to 0 if a alpha square plus b alpha plus c equal to 0, which means if alpha satisfies the given quadratic equation, then alpha become a root of a quadratic equation. Got it? We will see how it is. Here for this quadratic equation, these are the roots or zeros. Okay. Now let us assume this is alpha. On replacing -5 as x in this quadratic equation, x square, that is -5 square plus 6x, 6 times of -5 plus 5 is equal to 0. So on squaring, negative square, negative into negative positive, 5 square 25, positive into negative negative, 6 times of 5 30 plus 5 is equal to 0, plus 25 plus 5 together 30, 30 minus 30, 0, 0 equal to 0. So LHS equal to RHS. So -5 satisfying the given quadratic equation. So this is one of the root. You can also check with -1. So here what are -5 and -1? These are alphas. Right? Next. Thus, x is equal to alpha is also called solution of the quadratic equation, or we can say that alpha satisfies the quadratic equation. We have already discussed. Here -5 and -1 are the solutions, or we can say these two satisfies the given quadratic equation. Now here are some important note points you need to remember. First one, any quadratic equation can have at most 2 roots. How many roots? 2 roots, because it is quadratic equation whose highest degree is 2. So it will have at most 2 zeros. Sometimes both are same or different. Okay. Second one, the zeros of the quadratic polynomial ax square plus bx plus c and the roots of the quadratic equation ax square plus bx plus c is equal to 0 or the same. Already we have discussed. Zeros of a quadratic polynomial and roots of a quadratic equation both are same. Okay. Here we call zeros, in this case we call roots. Right? Next, different methods to find solution of a quadratic equation. What are all possible methods? We will discuss in this class. Okay. First one, by factorization. So by factorizing method we can find solutions of a quadratic equation. Second one, by completing the square method. By using this method also we can find. And the third one, by quadratic formula, by using formula as well. But this session we will mainly focusing on factorization method. Okay. Next, solution of a quadratic equation by factorization method. So what exactly we do? How we will find solution of a quadratic equation by factorization method? Let us see. To find the solution of a quadratic equation by factorization method, we first write the given quadratic polynomial as product of 2 linear factors. How we will write? Product of 2 linear simple polynomials. Okay. By splitting the middle term and then equate each factor to 0 to get possible roots of given quadratic equation. So once we get product of 2 linear factors, each factor we equate to 0. Then we get what? We get roots or solutions of quadratic polynomial. Okay. Now let's try to understand step-by-step procedure, that we can say algorithm. Okay. Algorithm for finding solution of a quadratic equation. Here is the first step. Write the given quadratic equation in standard form. What exactly standard form? That is, ax square plus bx plus c is equal to 0 is known as standard form of a quadratic equation, right? And then find the value of a, b and c. What are a, b, c are here? Here a, b, c's are coefficients of each term. Okay, here a is x square coefficient, b is x coefficient and c is constant. Also, let p of x is equal to ax square plus bx plus c, which means let us give some name for the quadratic polynomial. Okay, so what is that? P of x. Here in this case we given p of x. You can also give q of x, r of x, your wish. Okay, let us see example. X square plus 6x is equal to negative 5. This is given quadratic equation. So here negative 5 is in right side. So on shifting this negative 5 into left hand side to make it in standard form, x square plus 6x plus 5 is equal to 0. We know on shifting signs will change. Okay. Now this is called standard form of this quadratic equation. On comparing this equation with standard form, here the coefficients a value x square coefficient 1, b coefficient of x that is 6 and constant c 5. Let us give some name to this polynomial, that is p of x equal to x square plus 6x plus 5. Now step 2. Find two numbers p and q such that, here we need to find two numbers again. How they are? They should be follow these conditions. First one, sum of p and q is equal to b. When you sum up p and q, whose sum is equal to value of b, that is p plus q is equal to b. And second condition, product of P and Q is equal to AC, product of A and C, that is P times of Q is equal to A times of C. Okay, so in this example, A into C, what is A into C? 1 times of 5, that is 5, 1 times of 5, first condition. So we need to find two numbers in such a way their sum should be equal to B. So what I am taking, those two numbers are 1 and 5 only. Okay, there are no other factors, we can't split 5 as other factors, right? So 1 plus 5 is equal to 6. See, what is B? 6. So first condition satisfied. Second condition, 1 times of 5 is 5. So here what is AC? AC is 5. So second condition also satisfied. So P is 1 and Q is 5. Not only P is 1 and Q is 5, you can also switch. P is 5 and Q is 1. Doesn't matter. Okay. Next. Step 3. Write the middle term Bx as Px plus Qx. So middle term we need to split as Px plus Qx, and further take a common term from first two terms and another common term from last two terms of Px. Okay, so don't confuse, you will understand by example. Okay, finally we get factors in the form of x plus m and x plus n, that is P of x is equal to ax square plus Px plus Qx plus c. You can see in place of Bx, so Bx we split into Px plus Qx. By taking common from first two terms and second two terms and further simplifying, we will get x plus m into x plus n. Okay, here we see P of x is what? X square plus 6x plus 5. Now this is middle term. We are splitting this middle term into Px plus Qx, that is 1 time of x, that is x, and 5 times of x, 5x, x plus 5x. Together how much? 6x. Got it? Now from these two terms we are taking x common. Now here we are left with x, here we are left with 1, that is x coefficient. So x times of x plus 1, plus from these last two terms we are taking 5 common. So here we are left with x, here we are left with 5 coefficient 1, 5 times of x plus 1. Again from these two terms we have x plus 1 common. So on taking x plus 1 common, here we are left with x, here we are left with plus 5. So P of x is equal to x plus 1 into x plus 5. Look at what we have got in this form, x plus m into x plus n. So on factorizing this polynomial, we have got x plus 1 into x plus 5. Now final step. Now equate each factor to 0 and find the value of x. That is, put x plus m is equal to 0 and x plus n is equal to 0 separately and solve them for x. These values of x gives the required roots of given quadratic equation. So why we should equate to 0? Because these are factors of polynomial, but ours is equation already which is equate to 0. So we need to equate each individually to 0. X plus 1 is equal to 0 or x plus 5 equal to 0. So on simplifying further and shifting this positive 1 into this side becomes negative 1, and shifting this positive 5 into this side becomes negative 5. So x is equal to negative 1 or x equal to negative 5. So hence the roots of the quadratic equation are negative 1 and negative 5. Clear? If you look back in the beginning, we have said the roots of the equation are negative 1 and negative 5. So that equation is same as this equation, and how roots we have got you can see here. Clear? In this way we will find solutions or roots of a given quadratic equation by factorizing method. Now for better understanding, we'll discuss few more examples, right?